Hi everybody, I'm Sap Anderson from Autodesk, and today I'm going to do a little quick version of the talk I did at SIGGRAPH about OSL in Max. It's not exactly the same talk, it's edited a bit, but obviously I'm not doing it there. I'm here at home in my office again, but some people wanted to see what I presented, so here's a kind of a version. Going to explain the what and why and how of what we did, some problems we ran into, and some things that could be improved in the shading language itself, in OSL itself. So, we had some goals. We wanted to make writing shaders in Max much easier, put it kind of into the 21st century. We need to get a new modern set of procedural textures because the ones that exist from Max are quite outdated and old-fashioned and not as flexible as they could be. And we wanted it ideally to work in as many renderers as possible, and if possible in the viewport. So some decisions we did up front for the first implementation was we skipped closures. Closures in OSL is kind of like materials. There's various reasons we did this: lack of time, technology available to us, etc., etc. I'll get more into this later, but our implementation does not support closures. We use it basically for textures. We also skipped complex types like structs and arrays, and we tried to keep it really simple. We started almost exactly a year ago with the development, which means say August of 2017, and the first was purely intended as an execution environment of OSL, but then we got a little crazy and added some cool stuff, so it didn't end up as simple as we maybe thought at first. It ended up kind of cool. So the first idea was like, do what almost every other app does, find some directory, collect all the OSL files in that directory, make them show up as if they were procedural maps in Max, and you're kind of done. But then we had a different idea. The DirectX shader in Max actually works by picking a file, and when you pick the DirectX file, the node itself actually updates itself dynamically to the new interface. And we kind of like this behavior because then we didn't need many nodes, we actually kind of only needed one that could be dynamically linked to whatever OSL file you put into it. And to don't have to drag files around, we actually like the idea of keeping the files inside the scene files, basically as a string. Then you wouldn't ever run into the problem of me sending your scene, sending my scene to you, and you're lacking a shader. It will always be there embedded in the file. Then we got even more crazy. We decided to do both of these things, and on top of it, add an editor. So it shows up in Max basically three ways. We have the map called simply the OSL map, which is kind of the blank slate. Then we have a category of maps, which does exactly what I explained. It goes through, parses some directories, and populates all the shaders there into your material browser. And then, of course, we have the built-in OSL editor. So let me show what this looks like. The first workflow is to use the OSL category. If you pick something from the category, it just behaves like any other shader in Max. There's nothing specifically weird with that. You can edit it, etc. The second workflow is using the OSL map. The difference is now you load a file in and say, let's take the wiggles and connect it, and now I can tweak the parameters on my wiggles. But I can just go in and click, no, a different one, and check how the parameters now suddenly change to the behavior of the new one, and again to a third one. But the really cool workflow is if you have a shader like, for instance, this checkerboard shader, which is a little strange. When you turn up the scale, the checkers actually get bigger. So I look in the source code and see, I'm going to change this multiply to divide. I hit compile, and bang, I have a shader now that does what I want, and the squares gets bigger when I turn the number up. What if I want a new parameter like brightness for whatever reason? I just type it into the code. I multiply my color with brightness here at the end. I hit compile, and bang, we have a new parameter that I can tweak, and I can basically work with my shader interactively whenever I feel like it. So Max ships with 101 OSL shaders, all licensed under Apache 2.0. The irony was the first people to use them was the Blender community. I found that funny, and I actually encouraged this. There's a bunch of interesting ones. There's a 4-dimensional Mandelbrot, the randomized bitmap, the steampunk shaders, math, etc., etc., all sorts of things. Here's some example of what you can do with the OSL shader. This is the randomized bitmap that ships with Max, but this is an experiment I did with wood shading. This is not shipping with Max yet. It's a wood shader with knots, and this is just a cube and a teapot. So all the blocks, all the wood, the knots in the wood, the randomization of colors, everything is part of this shader. It will show up later at some point, maybe on the GitHub. An hexagon shader downloaded off the net, the raindrops shader, random dots. This is supported to be leopard dots, something like that. The rivet steampunk shader does ship with Max, and another example of my playing around with my wood thingy. Here's some half toning stuff I tinkered with. So this is Arnold rendering with its cartoon shader, but I'm using OSL to make this screen tone, as it's called. It's like a half toning that is in screen space. This is how you draw manually, traditionally, the anime, and actually cut out these half-tone patterns of actual stencils that you stuck onto the paper. To get this look in the rendering, I wrote an OSL shader. Here's another example of that with a crosshatch effect, and here's one with squiggly lines, etc. We want the OSL stuff in Max to be radically open, so we added a GitHub page, which is in that link. If you don't remember that link, you can just go to UncleBob'sShaders.com instead. What is that? Well, it's kind of a joke I put in the manual. It was an example of how you can use metadata in your shader to get additional UI in the user interface, and I came up with Uncle Bob's Shader Emporium. I thought it was funny, and I thought it was funny with UncleBob'sShaders.com. Then I realized, why not just get that domain and point it to the GitHub, so you can use that as a cheat. So here's an example of the OSL stuff working together with the physical material. So a bunch of OSL shaders and the physical material rendering in V-Ray and rendering in Arnold, and giving you effectively exactly the same results. Even though in Arnold it's actually Arnold executing the OSL in its built-in one, in V-Ray it's actually Max executing the OSL. Now for the how. The challenge was this: Max has many different renderers. It's probably one of the apps with the most renderers available to it. They all work differently, they all have different shading language, different APIs, etc. There's a lot of third-party renderers that are completely outside our, meaning Autodesk's, control. We can separate renders into 3 categories. The one using the original 90s style C++ 3ds Max shader API, or renderers that use the completely own shading system, which shading language or whatever, and those renderers that already support OSL. Obviously, the ones that already support OSL is pretty trivial. Actually, making this work in Arnold that already supports OSL was extremely simple. Renderers that do their own thing, there's not really much we can do about them, but renderers written originally for the original Max shader API, such as V-Ray, Corona, etc., we can make it work by actually plugging OSL into the classical shader API. So all you need to know about the classical shader API is this. Shaders in Max are simply C++ classes with particular interfaces. Textures have eval color, eval mono, and eval normal perturb member functions. And materials have a shade. They are both handed a shade context, which defines which point in space to shade, etc. This gives them some cool things. Max always had a strict separation of materials versus textures, where a material would map to anything in OSL that returned a closure, and textures would map to anything else. And doing it this way, like I said, support many of the third-party renderers written for the classical API, so this is awesome. Things that are not so cool though is that the shade, the interface on materials, is extremely outdated. It can't really do any real modern rendering. There's no way to glue multiple importance sampling into this. There's not even ray tracing. It works with light loops, and it's very, very outdated, unfortunately. So this is yet another reason we didn't do closures, because the API we had doesn't really fit with doing them. Now, The workflow for a 3ds Max shader is basically this. First, there's a function called update. This is called by the main thread when the shader states need to be updated. What it's supposed to do is to take whatever is in the parameter of the shader, information from the scene and all this kind of stuff, and then it's supposed to store it locally in the shader. Often for simple shaders it's just stored in regular member variables in the C++ class. And then there's the eval function, which is supposed to render. And these are called from the rendering threads. And rendering threads cannot touch the scene. They can only touch data that are in the shader themselves. Even though some actual shaders kind of violate this, which can be problematic in interactive rendering. For production rendering doesn't matter because the main thread is parked, but in active shade, interactive rendering, what actually happens that while the render thread is rendering and executing eval stuff, there will be an update happening from the main thread. And if this communication breaks down, there might be a crash. If the eval function actually goes to a pointer to the object and the update and the object might get deleted, for instance, well, that breaks. But it's supposed to do this. It's supposed to should update the internal information in the shader, and the eval function should only work with internal information in the shader. So what we did was to build a single 3ds Max texture called the OSL map. It's a subclass of texture map, so it's not a map, it's not a material. This deals with everything for every OSL shader in Max, regardless if they show up in the category or if they show up as the single OSL map. It's really the same class doing all the work. The only difference in one case has a file preloaded and the other case not. There's also a bunch of magic handling with all the dynamic stuff that I'm gonna completely skip here, which really has nothing to do with OSL itself, but just parameter blocks and loading and saving and all this kind of stuff. There's also a wrapper being added to handle bumps, because Max API toss around bumps as a normal perturbation, a change in the normal. And to make that happen with OSL, there's actually a wrapper shader wrapped around the root of the shade tree that actually computes this normal perturbation for you. So, what does the OSL map update do? Well, it starts making a temporary shading group. And then it calls one of its own functions called build shaders and parameters. I will explain on the next page what that does. Then it adds any wrapping shaders to optimize outputs and support bumps. And then it ends the temporary shading group. It tells OSL which outputs we want. This is really important because if we don't tell the OSL compiler which output you want, they actually don't get included. They get optimized away. And then you optimize the shading group, because then you have to tell it get the pointers, and you can't get the pointers to the outputs until you optimize the group, because things can move around while you do this. And then you assign the temporary shading group we did to the active group. This is what makes this thread safe. If this is happening in the main thread, the render threads can merely be running and using the actual shading group, and not until we have finished and updated and made our brand new shading group with the new values and the new settings, to one place just assign this variable, we'll just change this variable for the rendering threads, and the rendering threads will at the next call pick up the new one and start rendering with the new shaders, and it's all nice and safe. Now, this build shaders and parameters function that I mentioned exists on all the OSL maps, so they can call each other's. And the first thing it does, it walks the list of other shaders that are connected to input and recursively calls build shaders and parameters on them. This is to build up anything that this shader depends on gets built up first, basically. And then it walks all the list of parameters for this shader and sets each of their values. So you use the shading sys parameters call to do that. And then you instantiate the actual OSL shader with the shading sys shader call. I know this is a little backwards, but it's the way you do it in OSL. You say parameter, 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 shader. That's what actually puts in the shader and assigns the parameters you just listed before it to it. It's a little backwards to me. I actually thought the API would make more sense if you say, oh, make a shader and then set parameters to it, but that's just the way it is. Then of course we make any connections from the subshaders that we prepared up here and to our shader, which we are in right now. So to make an example, we have 3 shaders connected like this, and if the calling sequence will be this with the indented is basically the sub-level. So the update function does shade group begin. It calls build shaders and parameters on itself, which in turn then calls build shaders and parameters on this one, which sets its parameter and builds the shader. And same for this one. Sets in the parameters and the shader, and then we're back to this level and we set the one parameter blah, and we set the shader and we do the connections to connect this one, and then we're back in the update level. So we said we add the wrapper, we end the group, we optimize, we get the outputs, and we're done. That's the whole thing we need to do to communicate to OSL how we build our shade tree. And then in the rendering threads, we simply say execute and then get the values out. And the address is something we computed before, which points to the data value that we suck out and interpret. So that's just a few lines of code basically in the actual eval function. Very simple. Now, problems. First of all, there is quite a lack of documentation for doing any of this. I basically had to ask on the OSL, on this OSL mailing list, and somebody told me, yeah, this is the sequence of things you need to do. Also, of course, the problem was that you have to ask the renderers for the outputs you want, or you won't get them. And if you tell the render you need the output Bob, you actually get all the output Bob. There's apparently a way where you can say something colon Bob, so where something is the shader instance or layer as it's called in OSL, and then you get it for only one particular shader in your shade tree, the output Bob, and that's what you should do. I didn't know this, I just asked for Bob, and then it turned out or in the reality, of course, I asked for the out. All my shaders had an output named out, so I asked for out, which made every single shader be not optimized because every output called out thought it was used. So that was not good. You need to optimize before you can get the output address. Important. Working in the temporary shading group for thread safety is important. Different OSL versions is a big pain. Arnold uses slightly different OSL version to Max. The hash noise didn't exist in Arnold for a while, etc., etc. This is always tricky. This has been extremely stable, and Larry has been extremely responsive. The one kind of true problem we ran into had to do with decimal separators. That if you have your system, your Windows set to comma as a decimal separator, parsing in OSL actually broke down because it was using the system's string to number function, and then a constant like 0.123 in the OSL source code wasn't parsed correctly because somebody was looking for 0.123, which didn't obviously exist. 90% of the work is really management of stuff that doesn't have anything to do with OSL, dealing with the UI, all the magic, the specific stuff in Max, validity intervals, all this kind of stuff. So the OSL side of things is actually the easy side. It's really the application side of things which is tricky. By the way, why are shader instances in OSL called layers? I really don't like that. And one way we solved it, so if we want an OSL shader to call a regular Max shader, the way we implement it is that we plug in a special OSL shader that does a get attribute call, and the get attribute calls actually ends up in your render services that you write for your renderer. And the get attribute now throws a little token that we in the render services can convert back to the C++ pointer and call the pointer of the classical max shader and get the color out of it and plug that back into OSL. So we allow both directions of like regular max shaders calling OSL shaders and OSL shaders calling regular max shaders, which is kind of neat. Now, some improvements to the language that I would really hope we consider for OSL 2.0. The globals are kind of ugly. Like there's magical N, there's a magical P. That's probably okay, but the CI, which is an output, which is the closure output, that smells really, really icky. I would prefer if everything, at least on shaders, was explicitly declared as outputs if you wanted to use them. And to have a syntax with .r or .x instead of having, you know, a bracket 0 for the first component of something would be really, really nice. And we really would need native types for vector 2, vector 4, and color 4. There's an implementation in 1.9 that uses structs, and it's not very pretty because structs in OSL is super weird implemented in the parameter interface. So I would really, really wish we could move to real natively supported vector 2s and color 4s. I would also be able to call a shader from another shader explicitly by basically saying evaluate on an input and with overrides of some parameters. This gives some insanely cool new features, and it's probably not super tricky to implement. And of course the big elephant in the room is that OSL doesn't come with any standard closures, and that what really makes it fall down as a material interchange format, sadly. And is yet another of the reason we don't support closures, because how could we? Because if we support some closures and then we send out OSL to the other renderer, it won't have those closures and it doesn't work. So until we have a basic set that everybody supports, supporting closures is not really on the map. Then I had an idea. Maybe I should do a course in shader writing online. We'll see what happens with that. Making no promises whatsoever, but it's an idea. And that's it. Enjoy.